day, everyone. In continuation with our example problems for structural matrix analysis for trusses. This is now example number 3. You're now asked to determine the joint displacements, member, axial forces, and support reactions for the given truss, shown due to a combined effect of loading and a settlement of 1/4 inch found at support 3 of the given truss system. Use the matrix stiffness method. So we will use again the same example problem that we did from example number 2. Though in the given problem, it was then stated at node number 3 or support number 3, there was a identified settlement of 1/4 inch. So pag sinabing settlement, basically that is a vertical displacement or a vertical deflection on our support vertically on the hinge. So originally, if we analyze that, that is a 0, horizontal and vertical, but in the given problem, there was now an identified settlement or vertical deflection at node 3. So basically, mapapalitan lang naman yung deflection value nung D7. So just like what we did on our first example problem, on our second example problem of the same figure, same truss, same nodes, same number of elements, same locations and specifications on its near far nodes, and the locations of your force axis 1 to 8. Then we will then again compute the local stiffness matrix of each member or each elements. Identify the horizontal, vertical, length, cosine theta, sine theta, cosine theta squared, cosine times sine theta squared, and its stiffness of EA over L. After doing so, computing EA over L, multiplied it to a matrix of 1, negative 1, negative 1, and 1, which gives us the value of its local stiffness matrix. Then next up is to provide your transformation matrix, your global stiffness matrix, then properly numbered it using the near far nodes as you have specified on our figure over here for each member, just like what we did on example number 2. So U4, V5, U1, and V2. Then same goes on its columns. Then if you can't perform basic summation of structure stiffness matrix, you can then transfer or convert your global stiffness matrix on its structure's global stiffness matrix. So basically column to column, row to row, and so forth and so long. So fill up nyo lang yan. This will serve as the structure matrix only for member number 1. Then all of the rest will, the same procedure will then also happen to the succeeding members within the given truss. Same goes for problem member number 2, local stiffness, transformation, global stiffness, local stiffness, member 3, member 4, and lastly, member 5. Okay? After doing so, completing the structure matrix on each member, you can then simply add them up on our structure stiffness matrix. This will serve now as our global structure as our general global stiffness matrix. And after identifying the structure or the general global stiffness matrix, you can then perform the partitioning of matrices. So by partitioning of matrices, identify the known forces on our truss system, the unknown forces, the unknown deflection, and the known deflection. Just like what we did from example number 2. Then partition them, classify them. So after doing so, identify the joint load matrix, which are your known forces within the given truss. So from our example number 2, we have already identified that the forces on 1, 2, 3 axis are identified as positive 75, negative 150, and positive 75 kips respectively. And lastly, from previous example, D4 or the deflection at the 4th axis up until to the 8th axis was identified to be 0. But this time on this example, given that there will be a 1/4 inch settlement on support 3 or node 3 vertically. So on a vertical section or the vertical axis of node 3, there will be a vertical settlement. So pag settlement, negative, pababa. So meaning meron tayong settlement sa D7 na negative 0.25. Beyond that, D4, D5, D6, and D8 are still considered equal to 0. Then we can then perform augmented matrix for deflection. Again, augmented matrix for deflection, the known forces P1, 2, 3 times the 3 columns and 3 rows, 1, 2, 3, then 1, 2, 3, times the unknown deflection D1, D2, and D3, plus the augmented matrix on this section, U4 to V8, times the unknown matrix, times the known matrix, D4, D5, D6, which gives us D7 of negative 0.25 and 0. Simply multiply a matrix of 3 by 5 in dimension with a 5 by 1 dimension, which gives us equal to a dimension of 3 by 1. Okay, simplify. So this one, subtract that with this one, then inverse this matrix. So minus lang natin ito, parehas naman ng tawag na dito, dimension. So pwede nating i-minus yan kaagad. Then multiply it with the inverse of this matrix. Then eventually will gives us the new deflection for this truss system, which has an impending settlement on support 3 vertically downward. So hindi na siya parehas dun sa example natin sa number 2 dahil meron na tayong na-introduce na settlement at node 3 vertically. So after identifying the deflection D1, D2, and D3, we can then proceed on solving the augmented matrix for the reaction at the support of the given truss problem. So basically, kunin lang natin yung P4 to P8. Then this section of the structure matrix or general structure matrix, your 5 by 3, multiply that to the recently solved deflection D1 to D3, plus this structure matrix, multiply that again with the known deflection D4 to D8 and D7 of negative 0.25. That will simply gives us the reaction at the support 1, 3, and 4. So basically that is a 5 by 3 matrix multiplied on a 3 by 1 matrix. That is a 5 by 3, 3 by 1 is a 5 by 1 matrix plus a 5 by 5 matrix multiplied on a 5 by 1 matrix gives us a 5 by 1 matrix. So basically gives us the reactions at the support from P4 to P8. So as you can probably guess, of course, magkaiba na yan kasi we have already introduced an impending settlement at node 3, vertical settlement downward. So meron na tayong deflection, meron na tayong forces or reactions at the supports. So next step is for us to identify, of course, the end displacements and forces on each member of the given truss. So just like what we did from last meeting or from the last example, after identifying the deflection, the reactions at the support, of course, is for us to identify whether each member is in compression, tension, internal forces, and member deflection. Okay? So first step is for you to identify your tawag na dito, end displacement under its global coordinate system. So identify your near far node on member 1, which is U4, V5, U1, and U2, and just basically substitute the deflection on its global coordinate system. So meron bang deflection sa U4? U5? Wala. And we have recently solved U1 and U2. Substitute nyo lang dyan. Then to compute for the end displacement on its local ordinate system of the member number 1 on the truss system, basically multiplying the transformation matrix of member 1 with the end displacement under global coordinate system of member 1. Multiply that gives us the displacement on its local coordinate system. And lastly, multiplying the local stiffness matrix kasi nga na-convert na natin siya on its local coordinate system. So we can then multiply that on its local coordinate system. So may transformation tayo. Excuse me. Multiply the local stiffness matrix of member 1 with the end displacement of under the local coordinate system of member 1, which gives us the forces on member number 1 or on each member. So if Q1 is in negative value while Q2 is in its positive value, therefore that particular member is in tension. Either way, if Q1 is positive and Q2 is negative, Therefore, it is in compression. Same goes will be done on member 2. Identify the deflection on the global coordinate system of the given member. Convert by identifying the end displacement on its local coordinate system. Then compute for its forces. So compression C, tension C member 1, compression C member 2, tension C member 3, and don't forget, baka makalimutan nyo, remember, on node 4, meron tayong V7. May V7 pa ba sa iba? Wala na. Bale, node 4 lang. Member 4 lang yung merong V7. Tsaka, member 5. Member 4 and member 5. Don't forget, there is an impending settlement vertically downward at node 3. So, baka makalimutan nyo yan. So, V7, U8, U1, and V2. Substitute, compute for the forces. Member 4 has an equivalent force of 4.94, which is in tension. And lastly, member 3, which is also in tension. And of course, do not forget to present your summary by attaching all the identified forces, reactions on each nodes, deflections on each nodes, identified forces on each elements or members, deflections, and the applied forces. Applied forces, deflections, new values for our deflections. Ito yung ating impending settlement sa node 3. Reactions, reactions on each supports. Then the forces on each member. Okay, so that will be all for example number 3 using the direct stiffness method. Direct stiffness method with a known deflection. So next meeting or next lecture video will be I will talk about trusses that involves change in temperature analysis, structural matrix analysis for trusses that involves temperature changes, and hopefully we could cover as well the space trusses or structural matrix analysis for space trusses. They're just the same, but we'll just have to analyze them on a 3D dimensional perspective. Okay, so that'll be all on this example problem number 3. I'll see you on our next lecture videos. Bye bye.